Welcome back. In this lecture, we will talk about the integration of renewables into our energy system, and more specifically, the energy markets. Today, we are going to discuss how renewables impact market design. We are going to see to what extent the global energy policies impact the energy market. Furthermore, we will look into the ways in which governments try to support renewable energy. But let us start with a short overview of why there is a need for renewables. A big advantage of renewable energies is that it is renewable. To avoid running out of energy sources, we must transit from an energy system relying on fossil fuels, which have a limited supply, to renewable resources. Moreover, the combustion of fossil fuels also leads to the emission of carbon dioxide. Carbon dioxide contributes to the greenhouse effect and will accelerate global warming. This temperature increase causes changes in our climate and is therefore called climate change. Climate change forms the main reason for the European Union to issue policies to reduce our carbon footprint. This policy is implemented by the so-called Green Deal. Europe wants to stimulate the economy by innovating in such a way that we become less dependent on fossil fuels. Renewables and clean energy technologies play a key role here. In previous videos, we discussed how the market price is set. We saw that suppliers of electricity offer their bids typically based on marginal cost. Electricity generation based on fossil fuels has a high marginal cost because a generator needs to purchase gas or coal. Well, for renewable energy, there are no fuel costs. We don't add coal or gas to our solar panels. It is the sun that fuels solar panel and creates electricity production. And sunlight is free. This means that the marginal cost of electricity production by solar panels is very low. The cost only consists of capital cost and operating cost. And operating costs comprise only the cost for maintenance of the solar panels. Only the inverters may need some maintenance, for example. But typically for solar panels, the major cost component is the capital cost, which is the investment cost. And because the operating costs are low and the absence of fuel cost, the marginal cost of solar energy is extremely low. This means that in a market context, renewable energy based on solar panels has a fairly low marginal cost. The same applies to wind energy. Therefore, renewable electricity ranks low in the supply curve. It will therefore be called off by the market. If there is an abundance of renewable electricity, it may even set the market price. The market price for electricity will then be very low. So, what makes up the business case of renewable energy in the market? Well, we have the cost as discussed. And then we also have the benefits. The benefits are the value of the energy supplied during the lifetime of the project. So we have the capital investments now, and then during the lifetime of the solar panels, which might be 20 years, they produce electricity. And this electricity has a value that should cover the cost. At the same time, we could have the problem that when we sell the energy produced by solar panels on the market price may become extremely low because of the low marginal cost. In this case, the market does not provide sufficient revenues to cover the cost. Let's go back to a graph we've discussed earlier during the course. This is the graph of the variability of the energy demand in combination with available solar electricity generation and wind electricity generation. The variability of demand, the daily cycles, are shown in gray. That's actually the need for electricity by consumers during the week. Then this energy can be supplied by solar panels, which are in yellow, during the daytime. However, not during nighttime, of course, because there's no sun. It can also be supplied by wind generation, which is represented in blue. When it's windy, wind generators supply electricity. We may observe there is insufficient solar and wind generation to fully supply demand at several moments. During these hours, we are still in need of fossil fuel electricity generation. Or battery power, if that happens to be available, which is not often the case. But at other moments, there is so much solar and wind generation that there is much more electricity provided to the market than there is demand. And when there is a lack of energy storage, this means that the entire demand is being served by solar and wind generation. But, as said before, solar and wind generation have very low marginal cost. So the electricity price in the end will also be very low during these hours. This may pose problems for the investors in renewable energies. They have invested in their installations, but when they sell the electricity, the price paid by the market can be fairly low. Well, this is the reason why there is a need for public policies with respect to renewable energy. The basic message here is that renewable energy does not fully fit in the market dynamics because electricity markets are based on marginal cost, which is mainly dictated by fuel cost. But renewable energies have zero marginal cost because it's the sun that provides this energy for free once you have the investment. At the same time, at those hours when solar and wind energy does not provide sufficient energy to match demand, we need to have other types of generation available. But these generators, let's assume these are gas generators, need to run only a limited number of hours during the year. So they have a problem as well. We have to invest in gas fuel generation, but the number of operating hours is too low to make the investment profitable. Therefore, we have two challenges at once. We have a problem with renewable energy regarding what makes up the business case. Where are the revenues when you sell solar and wind generated electricity to the market? And we have the challenge of the business case for the emergency generation to guarantee supply security in those periods when there's insufficient wind and solar generation. These two issues, therefore, necessitate policies by the government to guarantee sufficient revenues for the investors to make the investments attractive to investors. Let's focus on the problem of renewable energies. The objective of government support for subsidy schemes is to compensate investors in solar and wind energy for the cost they have made, which are not earned back from the market. Take, for example, the case of a solar panel. There is a certain cost that is associated with the investment, and there is a certain operating time. Now one can calculate how many megawatt hours will be generated during the year and during the lifetime of the panels. And furthermore, one may calculate the net profit for the investor and the missing revenues over this period to make the investment attractive. Now there are several approaches to reimburse the investors for these missing revenues. One option is to calculate the difference between the cost and the revenues and compare this with the equilibrium price needed by investors to have an attractive investment project. Then the government will make up for the difference between the real market price and the required sale price for renewable electricity to make the project attractive. This is done by so-called feed-in tariffs. Of course, it's very important to set the correct price. At too low prices, it will discourage investment because investors will never recover the cost. A too high price, of course, will lead to windfall profits for these investors because they will be able to make huge profits. So for the government, it's important to set an appropriate subsidy. Another way to approach this issue is by adopting so-called quantity-based instruments. Here it's the government that sets a kind of minimum volume target of renewable electricity to be traded and consumed in the market. Because of this obligation, a new market develops. The market parties themselves will search which generators are able to generate this renewable electricity at the lowest cost and reimburse their fixed cost. By setting a volume of electricity to be generated from renewable resources, for instance 40%, it's the government who more or less forces market parties to make sure there is sufficient renewable electricity. And by doing so, the government incentivizes the development of renewable energy. For renewable energies to become a success in the energy market and to increase their share in our energy portfolio, there are several challenges to overcome as well. These challenges are partly based on the market design and partly based on the type of energy source. First of all, as discussed previously, we have the geographical dependence of some energy carriers. Some energy carriers better match with certain countries than others. If you have a lot of wind, investment in wind turbines makes more sense than for countries where there is not too much wind. And the same holds for solar panels, which would do better in warm and sunny countries than in others. Then we have the challenge that once we have a certain amount of renewable generation, there may be insufficient transport infrastructure. Typically, renewable generation is feeding into the electricity grid at locations with weak network infrastructure. The electricity grid was never designed to absorb electricity at those places. In this case, we need to expand the grid, which takes time. And in the meantime, we will have to deal with network congestion. A third issue is caused by the variability of generation. Electricity generation by renewable energy generators depends more on the availability of the resource, wind and sun, than on the demand. We have a mismatch between the supply profile and the demand profile, and we need to find a solution for this. As discussed previously, sector coupling and storage may play a role here. The last point is that the right financial incentives must be present for investors to invest in renewable energies. Investment in renewables will be tricky for investors due to the low marginal cost. We need a new market design in which the market provides the appropriate signals for such investments. This is the challenge for the coming years.